my name is Ruiqi. And my supervisor in both healthcare and education. The title of my presentation is Numerical Study of Mixed Convection in Partially Hotted Hybrid Nanofluid Field Coverage. This presentation continues 6 parts. The first part is introduction. What is a nanofluid? In general, nanofluid is a base fluid such as water, oil that contains dispersed nanoparticles less than 100 nanometers in size. A hybrid nanofluid is a type of nanofluid composed of 2 or more different types of nanoparticles. In this study, aluminum oxide and copper are used to select the nanoparticles and the water as base fluid. Because this hybrid nanofluid enhances thermal conductivity and heat transfer performance. Next, we consider 3 types of convections: natural convection, forced convections, and mixed convection. Natural convections is driven by Boolean forces that arise from changes in fluid density. Forced convection is the movement of fluid by external forces or pumps. And the mixed convections is a combination of the both convections. In this study, heated rotating cylinder induces forced convections. Thermal gradient induces natural convection. So, mixed convections is the subject of this investigation. Then is the problem statement and objectives. The main goal of this study is to investigate how this hybrid nanofluid can improve heat transfer in a square cavity with a hotted rotating circle object in the middle. Substitute it in a specific problem is to study influence of radius, angular velocity, and Rayleigh number on heat transfer in this nanofluid flow cavity. And there are 3 objectives. First one is to generate and develop this mathematical model in console software. The second one is to investigate the effects of radius, angular velocity, and Rayleigh numbers. The third one is to evaluate heat transfer over Nacelle number, streamlines, and isosense. The second part is literature review. The study of nanofluid has growth in a number of fields, including physical, medicine, and chemistry. In the realm of biomedicine, nanofluid has long been used, particularly in medication delivery. And Vaha et al. Found that hybrid nanofluids improve heat transfer in 2022. Then there are some related literatures. Coastal and Ramdo study a square enclosure supported by a revolving cylinder. Mohabi and Rashida investigate the behavior of nanofluid in L-shaped cavities. And Ashabris et al. Study the rectangular cavity that were filled with nanofluid and then get a clear correlation between elevated convective heat transfer and Rayleigh numbers. Therefore, this study focuses on radius, angular velocity, and Rayleigh number effects. Then is the third part, methodology. Firstly, we see the geometric. there is a 2D sphere cavity with central rotating headed circle object, and the left wall partially halted, right wall partially cooled. And other parts of the left and the right wall, top and the bottom walls are adiabatic. And the base fluid is water. The nano particles are aluminum oxides and copper. Then is the mathematical model. Firstly, we see the governing equation for hybrid nanofluid. There is continuity equations, momentum equations, and energy equations. Then considering the dimensionless parameters, summate these parameters in this equation. Finally, we can get the result no dimensional closed form of the governing equations and the boundary conditions. Next are the element dimensionless parameters. They focus on the real numbers and the natural numbers. Real number is used to measure the likelihood and the intensity of the natural convection, and it is used as a variable parameter in this study. Natural number is used to measure the relative strengths of convective and conductive heat transfer in a